Greetings, fellow mathematicians. We're going to take a look at another problem on finding the derivative f prime of x by using the limit definition. Now, in previous problems, which I have linked down below in the description, we've gone through applying the limit definition to the standard types of functions, basic polynomials, typically of degree 2 or degree 3, and then basic rational functions, functions defined by fractions. This problem, we're going to go through the other standard type of function, which you'll be expected to apply the limit definition to for finding a derivative. And here, that's a basic square root function. All right. Now, let's point out the limit definition of the derivative that always gives an indeterminate form of type 0 over 0. Now, earlier in your Calculus 1 course, you were likely introduced to 4 standard algebraic tricks for eliminating the indeterminate form of type 0 over 0. And for expressions involving square roots, the standard algebraic trick is multiplying the numerator and denominator by the conjugate. So here, we're going to keep that in mind since we have a function defined by a square root. Now let's just briefly review what the conjugate is. If we have an expression here involving square roots, square root of a minus square root of b, the conjugate, we just change the minus between the terms to a plus. And had that been a plus between for the expression, the conjugate has a minus. So basically just change the sign between your single or here two square root expressions, and that will give you the conjugate. All right, so let's go ahead and start with our first step. We're going to replace x with x plus h. All right, and that's really simple here. We just get the square root of x plus h. And there's nothing that we can do with that. There's a common mistake that gets made here, and that's students trying to think of this as the square root of x plus the square root of h, which that does not work. The mistake there is usually made because students think that addition works like correctly if there were multiplication there. If that were square root of x times h, then you could split that apart with a multiplication in between, but not with addition. So just be careful, don't make that mistake. All right, so this really doesn't simplify. We're going to go on to step 2, calculating the difference. So f of x plus h minus f of x. And this step is really simple. We just have this expression, the square root of x plus h, and we're subtracting the original function f of x, which is just subtracting square root of x. All right, again, nothing simplifies here. We're going to go to step 3. We're going to divide that by h, and that's where we're going to multiply the numerator and multiply the denominator by the conjugate. You can do that here, but I usually like to go to the next step where you have a fraction. All right, so let's write this out. We have in the numerator f of x plus h minus f of x. We're dividing that by h. So we're just going to copy these terms down. That's our numerator. Square root of x plus h minus square root of x. That's over h. And here, this is where we're now going to look at that numerator as our square root expression. And we're going to multiply the numerator and denominator by its conjugate, which is changing that minus to a plus. So take your time and write this out. We have now the square root of x plus h, but now plus square root of x. You have to multiply the numerator by that, and then multiply the denominator by the same thing. What we're doing here is multiplying by 1, which you're always allowed to do algebraically. All right, now the work involved in simplifying this to make use of the conjugate is in multiplying out these two numerators. And the goal with taking an expression and multiplying it by its conjugate, there should be no more square roots or radicals left after that. So let's go ahead and work that out over to the side. So we have here square root of x plus h minus square root of x. And we're multiplying that by here, the conjugate, the other numerator, which is square root of x plus h plus square root of x. Now from here, we're just going to do basic foiling. We're going to multiply that out. And just be careful, you're going to end up with square roots being multiplied by themselves. So a square root times itself, that just cancels and gives you the quantity inside. So here, when you multiply your first terms, you're going to get x plus h. All right, we're going to multiply the last terms, so plus square root of x times square root of x plus h. All right, we're going to multiply the inners, so minus square root of x times square root of x plus h. And now multiplying your last terms, notice the sign comes out to be negative. You have a negative times a positive. But you now have square root of x times itself. That's going to cancel out to leave you with just x there. So at the end here, we have minus x. Now, you see there's still square roots, but the signs are going to have those cancel out. And at that point, there are no more square roots or radicals, which is what we wanted. Now, you can even go a little bit further. Notice you have x and negative x. Those cancel as well. So really what we're left with is h. And that, again, passes our consistency check. Once you fully simplify using one of your typical or standard algebraic tricks, you should find you're left with terms that contain h. And that was the numerator. So let's go ahead and write down the simplified result. We're again going to use a standard tip that I like to give to my students. Keep this denominator factored. So in other words, you don't have to distribute this h into each of those terms. So let's go ahead and write this. Keeping the denominator factored, we're going to keep that factor of h out front, and then a set of parentheses inside will be the other denominator. All right, and the numerator, that's what we just worked out over here, taking the expression and multiplying by its conjugate. That's simplified to just h. And notice at this step, the h's cancel out, which is what you probably expected and anticipated. So here, what we get as our simplified result for step 3 is 1 over the square root of x plus h plus square root of x. And here we are practically done. We just go to our last and final step, take the limit as h approaches 0. And we get our derivative, what we call f prime of x, defined as the limit as h approaches 0 of this expression. The end result of step 3. 1 divided by the square root of x plus h plus the square root of x. All right, and since there is no more indeterminate form, I always make a point to point this out. Your indeterminate form has canceled out right here. You can now evaluate this limit by plugging in h is 0. And if you do that, notice you're going to get inside the first square root, you'll get x plus 0, which is just x. So in your denominator, you can write that term as square root of x. But your denominator also has plus another square root of x. And just go through some basic algebra. You have a quantity being added to itself. That's now two of those quantities or terms. So you can write your denominator here as 2 times square root of x. And that is our derivative. This was the last of the standard types of functions that you'll be expected to apply the limit definition to, likely on your first test or exam. So here, if we just write down what we've gone through, we started with our function f of x as square root of x, and the derivative f prime of x using the limit definition. This comes out to be f prime of x equals 1 over 2 times square root of x. And there we go. Now again, the point here was using the limit definition of the derivative. Likely right after this in your Calculus 1 course, you're immediately going to get to the power rule. And you can go through this problem in seconds by rewriting this as x to the 1/2 power. Right now, again, our focus is on the limit definition. All those rules and shortcuts are coming up. Hope you enjoyed the problem. I hope you're learning a lot. If you are, support the channel, like and subscribe.